A block is dragged along a surface using a massless cable as shown, and a tensile force Ft has a magnitude of 3 newtons, and the kinetic friction force has a magnitude of 2 newtons. And we've drawn a free body diagram, and we're asked to determine the work done by each force if the block moves a distance of 4 meters. Well, the work done by the force of weight is equal to the work done by the normal force, which is 0 joules, because these forces are perpendicular to the distance vector. Now the work done by the tensile force is equal to the magnitude of the tensile force multiplied by the magnitude of the distance vector, which is 4, cosine of the angle between them, which is equal to 12 root 3 on 2, or 6 root 3 joules. And the work done by the friction force is equal to 2 by 4 by cosine 180 degrees, so we get a negative here, and that's equal to minus 8 joules. A ball with a mass of 2 kilos is rolled up a frictionless plane, and we're asked to find the work done by all forces if it travels 3 meters up the plane. So I've drawn in the force of weight and the normal force, and the work done by the normal force is 0 joules because it's always perpendicular to the displacement vector. Now for the force of weight, we can resolve it into tangent components and normal components to the plane, or we can use a dot product directly to evaluate the work done by the force of weight. So by the dot product, that's equal to the magnitude of the force of weight, which is the mass of the ball by gravity, and multiplied by the magnitude of the distance vector, which is 3 meters, and that's multiplied by the cosine of the angle between the two vectors, which is cosine 120 degrees. So what we obtain is 2g by 3 by minus a half, or minus 3g joules.